Hi, everyone, and welcome to this episode of Crowded Beaker Solves. Today, we're continuing again our series on isotope notation and questions involving isotopes, versions of elements that have the same number of protons but differing numbers of neutrons. And I've already implied that sometimes you'll see isotope notation with charges attached to that. And that is because, yes, the protons determine what it is, the neutrons might be different, and also the electrons might be different too, because they might have given away some electrons. Electrons might have been added to that atom. And because electrons are negatively charged, whenever you add or subtract electrons to an atom, it changes the overall charge of the atom. So we're going to get into it. We're going to see a couple of isotopes today that have charges, and we'll do it in this format. Write isotope notation for an atom that has 37 protons, 48 neutrons, and 36 electrons. Notice that those are not the same this time as they have been in previous videos. So process starts the same though. I first have to go and find which element has 37 protons. So it's down here lurking in the fifth row of the periodic table over on the left, and that is the element rubidium. So really nice element there. So we'll put the symbol Rb, and the 37 protons goes on the bottom. So we got that. Nice. And just like last time, to get the top number, the mass number, I need to add up 37 plus 48, which gives me a total of 85. And that should be the top number. So again, if you need more review on where to get that number, you can also watch the previous videos as well. But what to do with this weird number of electrons here? Well, it turns out that rubidium, because it's an alkali metal, it does the thing that alkali metals do and dumps an electron away. It has an extra electron that it just doesn't want or need very much, and so oftentimes it loses it. And so the electrons goes down, and this is the tricky part. This is where common errors are made. A lot of people think, oh, because it lost an electron, it went down, it must have a charge of -1. Okay. And it's a good start. It's a good to wrestle with this idea, but it's actually the opposite. You have to think the word opposite when you do these. Because electrons are negative, if you lose a negative, it's almost like gaining a positive. Okay. And another way to think about it is that now you've got 37 positive protons and only 36 negative electrons. And so you actually have an extra one proton, extra one positive that makes the entire ion into a positive one ion. That's a cation. And so if you lose electrons, it goes more positive. If you gain electrons, it goes more negative. So you have to kind of keep that in your head, in your thoughts as you do these. And watch out for those times when the electrons and protons don't actually match, because that should show up at some point. All right, so I have one for you to try. And in case you're wondering, yes, I did already solve the pause the video problem, unlike the last video when I just went ahead and did it. But here's the prompt. We're going to write isotope notation for an atom that has 53 protons, 78 neutrons, and this time 54 electrons. So grab your periodic table, pause the video, and see if you can come up with isotope notation for this one. And if you were able to find out that element number 53 is iodine, lurking over here on the far right of the periodic table, and put that there. 131 is your top number, the mass number, because you added up 53 and 78, and 54 electrons, because now we have an extra electron, which is negative. That makes the charge negative on this isotope. So, remember, add electrons gets it more negative. Subtracting away electrons makes it more positive. All right, so there you have it, a couple of isotopes with charges. If you have any questions or suggestions for me, send them to me. In the meantime, happy notating and have a great day.